Our AI agents can build our entire backend in minutes. Then we ask it for one waterfall chart, and it hands you 100 lines of Vega-Lite that renders a blank page. We blame the model. Microsoft Research just published a bet that everyone's wrong. It's not a model problem, it's a language problem. This is Flint. And it fixes a pattern you're about to see everywhere in AI tooling. So stick around, even if you've never chart anything, because this might just change how models and languages work together. The project is called Flint, and the idea clicks once you see the chart generation is secretly two jobs. Job one is meaning this column is month, that one's revenue, and that one's a percentage change. LLMs nail that. Job two is geometry, axes, step sizes, scale domains, label spacing, color ramps. LLMs are bad sometimes at geometry, and that's exactly where your generated charts kind of die off. The Flint team hits this wall themselves, building their own analytics agent that measured roughly 80% success on good-looking charts. Sounds decent until real users are on the other end, and 1 in 5 charts is broken. So Flint splits the jobs into two. The model writes about 10 lines of JSON that only describe meaning, using semantic types, quarter, price, rank, percentage change, over 70 of them. Then a deterministic compiler takes over, makes every geometric decision, and emits a real Vega-Lite, eCharts, or Chart.js spec. The model does meaning, the compiler does math. That's the whole trick. If you enjoy coding tools that speed up your workflow, be sure to subscribe. We have videos coming out all the time. Now, watch how fast this gets. Setup is one line. Claude MCP add Flint. It's pure TypeScript on Node 18. There's nothing weird on Apple Silicon. I paste in a CSV of monthly signups and ask for new users by month per game as a heat map. Claude writes a 10-line Flint spec, calls render chart, and the finished PNG drops into the chat in seconds. Rendered locally so my data never left my computer, but here's the part I didn't expect. There's a tool called Create Chart View that opens an interactive panel. I didn't have to reprompt, and I didn't spend any tokens on that. The model finished its job, and the chart is still editable. So here's what's actually happening now. Everything hangs on those semantic types. Watch this. I change one word, the column tagged quantity becomes percentage change, and the compiler flips the entire color scheme to a diverging palette, rewrites the number formatting, and rescales the axis. One word in, a dozen correct decisions out. Now, think of it like this. You tell Flint what the data is, never where the pixels go. And because the output is genuinely Vega-Lite or eCharts or Chart.js spec, that means same input, pick your backend, there's no Microsoft rendering island here. The compiled spec is yours to hand tune. It's an intermediate language that gets you 95% of the way. It's not a replacement for anything. Now, the question someone in data science, or you, are already asking, don't we already have Vega-Lite for this? Here's the thing. Flint isn't fighting Vega-Lite, it compiles to it. Vega-Lite feels high level right up until you want the chart looking good, and then a waterfall chart balloons past 100 lines of coupled parameters. The same waterfall in Flint, about 10 lines, because the compiler owns all the weird parts. Then we have Mermaid, but that's for flowcharts. Hacker News said the quiet part out loud. You don't ship Mermaid charts to customers. And those chart MCP servers with 26 separate tools that render your data on someone else's server. Flint is 5 tools, 1 schema, all local. Now, the caveat with all this. First, this is a research project. It's not a product. It's about 2 months old, version 0.2, 8 contributors. They were still catching bugs this month where the same spec rendered differently in Vega-Lite and in eCharts. Then that viral sounding claim of 100,000 tokens down to 200 per chart, there is a cut. The author's own number, 0 benchmarks, the paper is still coming soon. Then yes, the sharpest objection here was frontier models already one-shot simple charts is just fine. If you're a power user with a big model, Flint solves a problem you don't have. The case for this is a bit more narrow, small or cheap models, composite charts like waterfalls and sunbursts, and any product where an end user sees the chart in 80% isn't good enough. Also, there's no maps in here. There's no 3D, no network graphs, no layering. Accessibility is literally an empty GitHub issue. In Python devs, there is no package yet, so don't go looking for it. The adoption says something over 5,000 NPM downloads a week for a 2-month-old research drop, and it already powers Data Formulator, Microsoft's own analytics tool, which means Flint has a customer inside the building keeping it alive. The most agreed on take here wasn't about charts at all. It was that all agentic systems are converging on exactly this shape. The LLM emits a tiny validatable intermediate representation, and a deterministic layer does everything else. You can validate 10 lines of JSON before it even renders. You can't validate 100 lines of generated D3. If you enjoy coding tips and tricks like this, be sure to subscribe to the Better Stack channel. We'll see you in another video.